Alright students, today we are doing part 2 of notes 3.4, find and use the slope of lines. Okay, now's a good time to go ahead and pause the video so that you can look at all these lines that you were supposed to graph. Make sure that the colors and the lines are going the same direction, and make sure you make any necessary corrections that you need to make. Alright, now that you've double-checked all of your lines and made sure that you graphed them correctly, let's go ahead and move on to the next page. In the next page it says, refer to the graph on the previous page, so we're going to keep flipping back and forth. Describe the relationships of the lines with the same slopes. So here, you need to look at your information that you were given. 2/3 and 2/3, those are the same slopes. So we need to compare the orange line and the yellow line. Here's the orange and here's the yellow. This is -4, -4, so we need to compare line C and D, line C, line D, -3/2 and -3/2. We need to compare line E and F. Here's E, here's F, and finally line G and H, line G and H. Alright, so as I was pointing those out to you, what probably popped into your mind was that these lines never intersect. When two lines do not intersect, we call those lines parallel. So that is the relationship. Describe the relationship of the lines with the same slopes. We do that by saying same slopes, they generate parallel lines. I want you to go ahead and box this concept because this is a concept that we are going to use quite often. You might want to get out a marker or highlighter and highlight that just so it pops out at you. Same slopes mean parallel lines. Now, parallel, we don't have to write the word parallel every single time. We have a shortcut, a symbol that we use for parallel. The symbol that we use looks like two uprights. It looks like the L's in parallel. And to use this symbol and to write that, describe that two lines are parallel, we write A is parallel to B. Now over here, A and B, those were the orange and the yellow lines. Notice how I didn't label each one of these lines because that would make this graph way too congested, and it's already congested enough as it is. That's why we used color to pop the lines out at us so we could find them easily. However, remember that when you're naming a line with a single letter, it's a lowercase script letter. So we write lowercase script, that's my lowercase cursive letter A and B. We also know that C is parallel to D. We can also say that E is parallel to F, and that G is parallel to H. Okay, then it says, now look at the graph and say, which lines appear to be perpendicular? Remember, perpendicular, I'll go ahead and write this now. Perpendicular, the symbol for that one is an upside down T. And if you look at this upside down T and the two lines and how they intersect, they form right angles. So what you're looking for are lines that look like they form right angles. The very first one that pops out at me is the red and the pink. The red one is line C and the pink one is line H. Another one that pops out is the orange and the green. Orange and green. I'm going to go ahead and write that one down. The orange one, the slope of it is 2/3. And the green one, line E, that one is -3/2. So take a look at the two different slopes. Notice how one is flipped one is positive, and one is negative. When you have a number that's flipped around, we call that a reciprocal. And when one's positive and one's negative, we call it the negative reciprocal. So that's going to be the relationship. Negative reciprocals they form perpendicular lines. Okay, and I went ahead and I boxed that because that's another concept that I want to remember. All right, so back up here where it says which lines appear to be perpendicular, those are the negative reciprocals. So that's going to be A is perpendicular to the green one, which is E. A is perpendicular to E. We can also say that C is perpendicular to H, the red one, and the pink one that I pointed out earlier. And B and E, B is the yellow one, and E is the green one. So yellow and green, there's another one. So B is perpendicular E. And we can list all of them, but there would be a lot to list. Let's go ahead and do the next one. Write an equation for the lines in numbers 1 and 2. We're going to change that to number 3 and number 7. Okay, number 3, remember that was line C. And in mine, that's the one that I colored red. And number 7, that was line G, and that's the one I listed as brown. Okay, so if you look at those, here, line C, -4, and this one is 1/4. So the slope, I'm going to write that as, use the letter M to represent slope. The slope of this line C was -4, and the slope of line G was positive 1/4. Those are clearly negative reciprocals. Whenever we were writing an equation for a line, we normally recognize it as y equals mx plus b. So I have the m. Now I'm looking for the b. B, beginning. Where does a line begin? A line, there's no beginning or end to a line because it goes on forever and ever. So what we do instead is we look to see where it crosses the y-axis, because we think of the beginning of a graph as the origin. So where it crosses the y-axis, we use as the b, the beginning. So if you look at the red line, where is it going to cross? It's going to cross at -3. Where does the brown line cross? It also crosses at -3. So here I'm going to say b equals -3, and b equals -3. So my equation for line C is y equals -4x minus 3, and this one is going to be y equals 1/4 x minus 3. Let's cross this out here because we're not using it this year. Compare the equation with the equations in line or in number 12. So we want to compare the equations in number 12. How do these two compare? Well, what is similar? What is similar is the y-intercept, the b, and what is different is the slope. Okay, and finally we have the graph, and we want to graph this equation. To graph it, again, we needed my equals mx plus b. And when we have y equals mx plus b, then it makes it a lot easier to graph. That means I want to solve this for y. So I'm going to subtract 2x from both sides. I get 4y equaling negative 2x plus 8. Divide by 4 all the way through. That means y equals negative 1/2 x plus 2. Okay, so my m of this line is negative 1/2, and my beginning is positive 2. So over here on my graph, this is my x axis, this is my y. Where does it cross the y-axis? Positive 2. I put a dot there. And now to get all the other points, what I do is I use my slope. This says down 1, right 2, down 1, right 2, or I could go up 1, but I have to go back 2. Okay, using my straight edge, I'm going to connect my dots, and there's my line. And that's it for notes 3.4.